Now we are interested in finding, guys, how do we solve a quadratic inequality. Quadratic inequality means a quadratic expression like the above expression. If I replace it by greater than, less than, 0, less than, equal to 0. In short, if, or in factor form also, like it is 2x minus 1, 3x plus 4, less than 0, let's say greater than 0, greater than, equal to 0. These type of examples they belong to what we call a quadratic inequality. On the left hand side, the quadratic expression is there. The generalized format of a quadratic inequality may look like this: ax square plus bx plus c greater than, less than 0, greater than 0, and so on, greater than, equal to 0. Okay, so we are interested in solving a quadratic inequality. We will do it by two methods. Okay, now we will discuss method 1, for which I will take an example, guys. So let's do method 1. What is method 1? We are method 1 for solving quadratic inequality, guys. Okay, so method 1 we will discuss by taking an example, guys. So let's say fx is 3x minus 1. So number line I will plot x. This vanishes, fx vanishes at, means fx becomes 0 at x equals to 1 by 3. So I can write for fx equals to 3x minus 1, 1 by 3. Here I will write plus, here I will write minus. Plus indicates fx is positive for all the values greater than 1 by 3, and fx is negative for all the values lesser than 1 by 3. Similarly, if I take another example, let's say gx. Okay, let gx is 2x minus 7. So in the similar way, if I plot 2x minus 7 vanishes at x equals to 7 by 2. So 2x minus 7 can be plotted like this, guys: 2 by 7, or let's say this is, I make it 17. Okay, this is 17 I make, so 17 by 2 it is. So this is 17 by 2. Again I will plot plus and minus. Okay, so we took two examples of polynomial: a fx 3x minus 1, b gx 2x minus 17, and I plotted on both the linear expressions signs on the number line. Okay, now what if we are interested in finding the product of these two, guys? See, what I mean to ask is, if I multiply fx into gx, okay, so fx into gx is 3x minus 1, 2x minus 17, 3x minus 1 into 2x minus 17. So I will plot for 3x minus 1, we know 1 by 3, it gives plus and minus. Okay, so, and for x equals to 17 by 2, okay, 3x minus 1, and this is for 2x minus 17, guys. This is what we did, plus and minus. Now if I plot both of them on the same, these 2 points on the same number line, guys, what I mean is 1 by 3 I will plot, 17 by 2 I will plot. Now I am interested in their product, 3x minus 1. What is the sign of their product? 3x minus 1 into 2x minus 17, guys. Okay, so what we will do now, as you can see here, I will join this, I will join this. Now for x which is greater than, now I will write the sign of these two. Okay, now see here, this is plus, this was plus, so here also it is plus, obviously. Now here it is minus, for 2x minus 17 this is minus, so here also it will be minus. Okay, right? So now we got 3 intervals on the number line. One of the interval is minus infinity to 1 by 3, and another is 1 by 3 to 17 by 2, and the last one is 17 by 2 to infinity. We got 3 intervals. So now since I multiplied these two, what I will do here, the signs will also get multiplied, minus into minus. See, this is this minus sign, this minus sign, this minus sign I wrote here into here. Okay, similarly if we take plus, if you multiply plus into minus, what we will get? We will get plus into minus, plus into minus. Similarly if you multiply plus into plus, okay, plus into plus, if you multiply, guys, plus multiplied by plus sign. So below this line, below this line, I will write the sign of the expression of the product of these two linear inequality, which is a quadratic expression, guys. Linear expressions, if multiplied, they give quadratic expression. So minus into minus, it gives what? It gives plus. Similarly plus into minus, it will give minus. Similarly plus into plus, it will give plus. So for 3x minus this 3x minus 1 into 2x minus 17, guys, into 2x minus 17, let's say this is some quadratic expression hx, the sign that we got was this 1 by 3 followed by 17 by 2 plus minus plus. Okay, now in the similar way, if I ask you, let me give you a problem, plot the sign of hx equals to x minus 1 x plus 7 on the number line, on number line. The same way what you did, the same question I am asking you guys on the number line. So what you will do, guys, we will plot each one of the linear expressions x minus 1. Okay, I will plot for x minus 1, it vanishes, x minus 1 vanishes at x equals to 1. So I will plot 1 here, and again plus and minus I will write. Now again for x equals to x plus 7 I will plot, which vanishes at, means when x plus 7 becomes 0 at x equals to minus 7, So I will plot minus 7 here. It is on the left side of 1, so I plotted it on the left side of 1. Again plus minus. Okay guys, now the same way what we did in the previous example, this I dropped a perpendicular here, from here I dropped a perpendicular here. Okay, now I extended this a bit. Okay, like this. Now again this is minus sign, so here also this is minus sign, so on the left of this is minus as well. Now again here it is plus sign, here it is plus sign guys. So after this also it is plus only guys. Okay, this is 1, this is minus 7. So if you multiply these two in the similar way, if you multiply these two, we will get a quadratic expression x minus 1 into x plus 7, whose signs would be minus multiplied by minus, the same way we did in the previous example, which gives plus sign. This is minus 7, again minus from above, and from x plus 7 it is plus. So minus into plus, it is minus sign, again plus multiplied to plus, you will get plus sign. So guys, this is 1. So for x plus 1 into x minus 7, x plus 7 into x minus 1, the signs are again the same that we obtained for x plus minus plus. Okay guys, so guys, as you can see from the previous two examples, x plus 7, x minus 1, we got the sign as plus, minus, plus. Similarly for 3x minus 1, 2x minus 17, again we got plus, minus, plus. So from these two examples we can generalize that if we have two linear factors are multiplied like this guys, x minus alpha into x minus beta, then if alpha is this, which is the smaller value, beta is this, alpha is lesser than beta, we will again have the same sign, plus, in the middle interval it is minus, in the left interval it is plus. Okay, this is method 1 that we derived by taking two examples. We can derive using alpha beta also, but it would be a bit abstract to understand. So generalizing with the help of these two examples, we can say that for x minus alpha, x minus beta, we get plus, minus, plus. Okay, now what is the meaning of, now how do we apply it in questions like alpha beta? If x minus alpha, x minus beta is greater than 0, what is x? This is the formula that we are writing, what is x? So using this plus, minus, plus, we can say that plus means positive, the expression is positive, so this we will take, and this we will take, that which is minus infinity to alpha union beta to infinity. So guys, this is x lesser than alpha or x greater than beta that is the answer, which is a formula. Other else you can also write it as x belongs to minus infinity to alpha union what? Yes, union beta to infinity. So both ways we can write. So this is the standard result for x minus alpha into x minus beta greater than 0. You can either write it like this, or you can write it like this, minus infinity to alpha union beta to infinity. Now if suppose they ask greater than equal to, in that case which 2 points we will include in the solution set? Yes, beta we will include alpha also, and in place of this square bracket, what will come, guys? In place of the square bracket, yes, round bracket, square bracket will come, guys. So that way, for greater than equal to 0, and here also less than equal to alpha, greater than equal to beta will come. So in that case, the result change would be, here there is square bracket, here also there is square bracket, guys. This is the result when greater than equal to is asked for. This is a standard result. Okay, so let's take an example, previous example, 3x minus 1, 2x minus 17, guys. Okay, x minus 7, 2x minus 17 greater than equal to 0. If the question is, guys, so as you can see, if you equate 3x minus 7 equal to 0, you will get x equals to 7 by 3, and if you equate 2x minus 17 equal to 0, you will get x as 17 by 2. Okay, so the smaller value we choose as alpha, the bigger value we will choose as beta, and directly we will use this result, and directly we can write the answer, guys, which is x belongs to minus infinity to the smaller value alpha, which is 7 by 3 closed bracket, union beta, which is the bigger value, 17 by 2 comma infinity, guys. Okay, or else you can write it in inequality form also, like this: equivalently x lesser than equal to 7 by 3 or x greater than equal to 17 by 2. That way also we can write. So this we derived using the what we call concept of sign. Okay, using two linear inequalities and multiplied them, and this is one of the method one of getting the solution of a linear inequality. Now what if instead of greater than equal to, they ask for less than equal to, guys, less than equal to 0. So let's see that, guys. So next is x minus alpha, x minus beta less than 0. So again, using this alpha, beta, plus, minus, plus, less than means negative, so our answer would be this, alpha to beta. So it means x is that is alpha to beta, that is the answer. Equivalently, in interval form we can write it x belongs to what? X belongs to alpha to beta open interval. Okay, this is another result. Now what if they ask if it is less than equal to? So if it is less than equal to, beta will be included and alpha will be included. Here also x greater than alpha, it becomes greater than equal to alpha. X less than beta becomes x less than equal to beta. And here in place of round brackets, what we will have is square bracket alpha to beta both included, guys. That's how we will do. So for example, if I take x minus 1 into x plus 6 less than equal to 0, so if you see, it vanishes, this linear factor vanishes at x equals to 1. Another linear factor vanishes at x equals to minus 6. Minus 6 is lesser than 1, so minus 6 would be assigned to be alpha and 1 would be assigned as beta. We can write the answer. We are finding x. We can write the answer as x between minus 6 to 1 using this formula. Although this is for equal to, so equal to sign won't come, so we can use this formula. Or equivalently, we can write it as x belongs to open interval minus 6 to 1. Okay, so that way we can use. Now as you can see here in the formula, alpha x, the linear factors are given to be, the coefficient of x is 1 here, but in this question, in this example, the coefficient of x is not 1. So what I want to emphasize here is this is valid when the coefficient of x is positive. Even if it is not 1 and it is something else, doesn't matter. So that's why here the coefficient was 3, here it was 2, still we can use this formula, and that's why we use this formula in this. Okay, minus infinity to 7 by 3 union 17 by 2 to infinity. Okay, but if x, coefficient of x is negative, that case we will see, guys. Okay, so we will see more examples.